Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill. This is my shop. We're working on an LBSC Tich locomotive, and this is what the chassis looks like. It hasn't changed much since the last time you saw it. Here's the book, that Simple Locomotive Building by LBSC. That's a pseudonym for the author. And in this week's episode, we'll talk about the cylinder covers and drilling and fitting them to the cylinders. And it's been a pretty interesting experience. As you can see, one of them came out just visually looking a little bit better than the other one. This one came out nicer. This is the first one I did, and I had to notch the gland boss there a little bit. But I'll talk about that in the video, and I'll also talk about this jig that I made using, this is a variation on the jig that LBSC describes, and it came in very handy. I would highly recommend making something like this if you're going to do one of these projects. So I hope you enjoy this week's episode. I have a special request from a viewer wanting me to say, you know how, if you watch this channel, you know I don't usually act like this, but a special request from a viewer who said he wanted me to say, mash that like button and ring that bell and give me a thumbs up. So I hope that makes you happy. I'm usually pretty laid back in these videos, but it is funny that the YouTube way of doing things. So I hope you enjoy. The next things that we'll be working on, I got to make some gland bosses from some 3/8" hex brass, or some packing gland nuts for the packing glands. I'll be making those first, and then making the pistons. These are the little chunks of cast bronze that came with my set of castings that I bought. And I don't think I'm going to use them because they're so tiny, but I do have a little piece of leftover bronze from a different project that's much larger than I need, but I think it'll work out well. So that'll be in the future episodes, and I hope you enjoy that. Stay tuned and enjoy the discussion of drilling and tapping and laying out the holes for the cylinder covers. Thanks a lot, everybody. Have a great week. I appreciate you being along on the journey, and look forward to talking to you soon. Thank you. Bye. Okay, the next step with the covers, now that I've made them and I got a good fit, is to figure out exactly the bolt spacing. I've done some tracings on this tracing paper that one of my daughters loaned me. I'm trying to figure out the best spot for them. You want the critical considerations. The fronts are not critical. You just need to miss the steam passages wherever you put your little bolt hole. The rear ones are more critical, obviously, because you have the gland boss in there. So figuring out the layout is important. Here's I've drawn a little line with Sharpie marker where the steam passages are. So you see, not only do we have to consider the placement of the steam passages, but also the flange here. So in other words, the right one over here, it's going to be over here somewhere. Can't be that close. So the book doesn't give specific degrees or anything. It just says lay them out in a pattern that's shown on the drawings, which is actually a pretty good guide and probably sufficient. But I just want to take the extra time. I'm taking all this time to build this. I wanted to build it right. Anyway, when I figure out the spacing, then I'll be able to put it into this. And let me show you why I made this. This came out really good. As a matter of fact, it's a shame that the pistons won't be made out of steel, because I could use this material to do that. Watch what a good fit I've got here. I mean, it's a perfect sliding fit with no shake. And I did undercut it a little bit. So my plan, remember, is once I get the bolt circle laid out, I can put this in the mill. I can use the bolt circle, pitch circle diameter function, drill my holes, and then take this back to the lathe and part off. Then I'll have a washer with the matching bolt circle, and I also have a template I can just drop in there like this and use it to drill out the holes, and it'll be applicable for either side, with the caveat that it's you got a left hand and a right hand. So that's why the utility of having the washer, I can flip it around, and also the washer is hollowed out like that, and I can place that over the little edge there. That's a nice tight fit as well, and use the washer as my drilling template. So I should be able to, once I figure it out and put the bolt pattern in to my template, then I'll be able to use it, you know, on either side there. Let me show you the fit on this side. It's really good. I mean, very exact. That's about the fit that the piston will need to be. I mean, there's maybe a thousandth or a half thou of clearance. It's not a push fit. It's a nice sliding fit, but no excess, no shake. Okie doke, I'll keep you posted. So I had a little time to work on the Tich project tonight, and what I'm showing you here, I'm using the pitch circle diameter function on my mill in the DRO, and so sort of an inexact way that I use it, but I think a lot of people do this. I'm grasping a Sharpie marker in, and I've gone all the way around, played with the orientation a little bit, and I'm about ready to take this out. There's a little bit of interference just on this one bolt hole, but generally I'm pleased because you can see where the Sharpie landed on all the others. I think this is going to give me a good pattern that'll be useful for both left and right sides. And I wanted to check with the Sharpie first. This is the size of the actual tapping drill that will go through for a 256, so I'll check that in a second to make sure it clears. But I wanted to show you, here's how I got this far. First I drew a sketch, and I tried to figure out what the pitch circle diameter was. I measured the outside diameter here, the inside diameter, did the math, and I came up with a 0.840 pitch circle diameter for my bolt holes. And then the next part of the equation is to figure out the angles. So I laid some tracing paper, which I got from my daughter, onto the actual cylinders. You can see I did the left rear and the right rear ones, and I carefully marked out where the steam holes were, so it's pretty obvious, and converted that over to some grid paper, and then I just drew lines, and what seemed to make sense, I used a protractor to measure the exact angle and then the reciprocal angle for the opposite sides, you know, left and right hand. And I programmed that all into my pitch circle diameter function on my mill and have come up with what you see here. So pretty pleased about how that came out. I'm going to check in a second with a small drill and I'll show you that. All right, here's the closest interference hole, so to speak, with a number 43 size drill. This is the size drill that will be used for the clearance for the 256 screw. So it completely clears that the gland boss there. So I think we're good there. The next step to checking everything is to disassemble the gland, the actual thing, and I'll put my my blank in there, and we'll check that out in just a second here. I'll show you what I'm talking about. Okay, now that I've gone around the mulberry bush one time with what will become my drilling template, I think the spacing is right on. The numbers that I came up with for the degrees, there's plenty of separation there around the steam areas. The catch is, as you can see pretty clearly, I think I misunderestimated, as the politician once said, the pitch circle diameter. When I put a caliper on that and eyeball it, it's actually closer to 900 thou. So I'm going to do this. I'm going to take this out, clean it off, do it one more time with a 900 thou PCD, and I'll try it again with a brass one, one of the actual covers, the regular covers, just to see what 900 looks like. And once I'm certain that I've got it all perfect, then I'll go ahead and I can drill the tapping size holes, the number 50, and then put it back in the lathe and cut it off. Okay, here's the 6 bolt hole pattern with a 900 thou pitch circle diameter. I think you can tell that that's going to be a lot better, a lot closer to the middle of the gap. Now I'm going to put in, I'll take the drilling template out and put in an actual brass cap, and we'll see what that looks like. I am tempted to change the angles of that I'm using, but you know, because it's a little bit of more of a gap here than you need on the front cylinder pieces. Let me flip this around. This is the front one that goes here. A little bit more of a gap than is probably necessary for the steam passages. But the key is to have the holes in, you know, they got to clear the gland boss in the back. So I think that angle choice is really the perfect one for the rear gland bosses. So I think I'm going to stick with that. I'll use the, flip that around, don't get crossed up here. I'll make the template. I'm not going to do it tonight, it's kind of late already, but use the template to drill my drilling guide, and then saw off this piece so that I'll have the reversible washer size. And I may end up going ahead and drilling the clearance holes for all of these while they're you know, using the little jig I made. May as well, and then just do the cylinders, drilling and tapping them separately. I thought I'd show this real quick. Actually, upon further review, I decided to go with a little bit different bolt pattern, starting at 40 degrees and ending up at 320. So it's an 80-degree gap in between the two versus a 90-degree on this one. I think it's a little tighter. It'll probably work a little bit better. So I think I'm going to go with that. That's the 900 thou bolt circle on that one, and I laid it out on this here rear cover as well. So I think we're good to go. I'm going to take a little break here and go ahead and set up and drill the template. Alright, after all that talk, here's the actual drilling of the holes. This is the last one. You can see I'm taking it really easy because that's a number 50 drill. It's pretty tiny. That's the tapping size drill for the 256 screws. I'm just going down 20 thou or so at a time. It's 400 thousandths is the thickness here. If you can see this, I put the little cast iron spacer underneath because I didn't want to chew up my collets. And it's a good way for me to tell when the drill bit gets in there. Cast iron is actually pretty soft compared to steel, so anyway, that's the last one. The next thing after this, I think before I take this over to the mill, I'll actually go ahead and drill, while I've got the set up here, I'll drill out all the front covers anyway, might as well. And I'll do the rear ones separately. Alright, here's the second of the front covers with the clearance holes drilled. And I did use some crazy glue to help hold them in place, and a little piece of blue tape just to make sure they didn't wobble around because you're drilling down through the bronze into the steel. Alright, I'm cutting off the washer end of my special jig for locating the holes. It's taken forever. I'm like 70 RPM and I keep resharpening my cutoff tool because I don't want to break it. Almost there. Okay, making a little progress finally. I used my jig and I drilled the 6 holes. If you can see that pretty well. I drilled them on the milling machine actually, of all things, because I'm just not satisfied with the motor speed on the universal pillar tool. But now, as you can see, I'm definitely using the pillar tool for the tapping. Got a 256 tap in here, and since that's a two-handed operation, I won't be filming the actual tapping, but off to the races to tap all 6 of these holes and then do a test fit. Okay, one side done. Came out pretty good. I like the look of the little stainless steel 256s. I think that's about the right size there. So I'm going to do the other front one next, and we'll see if that comes out a little bit better than this one. In case you're wondering, here's the jig in action. What I did was I lined it up, marked it, cleaned it off really good, and I used crazy glue to hold it in place. And then what I'll do is heat it up with a heat gun to release the crazy glue, and then scrape glue off before I tap it. Here's the heat gun operation. I just pulled the thing in a little vise. I've got this nice Milwaukee heat gun that my father-in-law got a long time ago. I think he got it for scraping off paint and stuff, but it works amazingly well. Heats up really fast. I'll take the channel locks there and gently lift out the steel form in just a minute. I'm trying a little experiment here because I want to get the holes perfectly lined up and perfectly clearing the steam passages. So you can see these little two lines here. This is where the steam passages are. So I've set the jig up so it's about an equal distance either side for those bolts, and I've blackened the bottom of it here so that I can use my indicator. Next thing I'm going to do is place the rear cover in position, and you can see I've blackened that as well. So it'll take a scribe line, excuse me, and I'm going to eyeball it so it's in about the right position. Luckily the little center jig is a pretty snug fit, so it's not going anywhere. And I'm going to try to, I'll set up the camera stand a little bit, but I'll show you. I'm going to try to use my center gauge here, my height gauge, to scribe a line that will line everything up, and I can use the one jig for drilling all the holes. Let me see if I can show you that. Okay, here's the setup. First thing I did was set the assembly down on the face that's going to be bolted to the frame, and carefully mark the center across the center line of the front disc. And then, I don't know if you can see this or not, but when I made these rear covers, I scribed a line when I drilled the hole just to mark the center line between the big hole and the little hole. And so I just lined that up and held it all together with my fingers, and then scribed another line that goes across all three surfaces there. And I've got, if you see the funny light, let me turn this off. I've got an OptiVisor on that helps me see the lines, additional magnification. So anyway, I'm not going to drill the holes tonight, but I'm thinking that's a good setup. And if it is, see, what I can do is, let me take it apart. I can easily leave this unit lined up to drill these holes, and then my theory is to be able to take it out and I'd be able to use that scribe line. Move this out of the way. Line it up, and there we go. I can put a little dab of crazy glue to hold it in place, and then drill the holes through here, the very same registration holes. I may have to cut this off a little bit, the stem on the jig. I kind of hate to do that. I'll have to see how long my drills are. But that's kind of the theory I have in mind. That way I'm using one jig for both sides. Alright, here's step one of my idea. So I've carefully lined up those lines, and I cut the bottom of the stem off. Sadly, I cut it down to about 3/4 of an inch. It's not even at all, I just hacked it off. But lined the lines up and used some crazy glue to glue this in place, and then I set it upside down and in the mill and drilled the number 50 hole, because that's what size hole is there. It's the tapping size. Naturally, I have to drill out these parts, drill them out to the number 43 or 41 clearance holes, but you can see they all, where the holes are, they're in a good spot. So happy with that so far. Interesting, this one's a little on the close side, but it's okay. It clears the end there. I can always notch that out if I need to. I might do that. I might notch that out a little bit for the screw head. But clear the steam passages really well. So I'll put this in here. The next thing to do is heat this up, take it off, and then crazy glue the bottom of the jig into this with the line lined up on the base there, and drill those holes. Okay, there's the rear one mounted. As you can see, it came out okay, except for when I did the alignment, I twisted it to give maximum clearance for the steam chambers, the steam slots, and what that did was put this part into where the screw head is. You know, not enough clearance, honestly, so I relieved it with a little end mill, made a vertical cut, and it's fine. It'll work just fine, and in fact, when in operation, it'll be unnoticeable. So not a big deal, but the lesson learned is, excuse me, for the alignment for this one, I'm going to have it a lot more symmetrical, and it'll still be enough clearance. If I have this hole, that'll be the closest one to the steam ports. Let me show you. If I have it aligned like that, the hole will be over here. It'll be outside. As long as I'm outside of that Sharpie marker, I'm fine. So that's what I'll do. And let me show you the planned result. So that'll go in about there, and then the rear cover, if it's vertical, you see it's still going to be close with the clearance on both of these, actually, but I think it'll be fine. I think that's probably as good as it can get us to be something like that. So I'm pleased with my technique anyway, with using the little the alignment and scribing that line there on the bottom. I'll do a different one, obviously, for this side, and it'll be in a different place on this ring, but it'll work out well for drilling the holes in the top and the bottom. So I'll go carry on with that and see how it goes. Okay, this is for the right side cylinder. I used the surface plate and my height gauge there. It makes such a nice scribing line, and excuse me, let's see if I can get that to focus. Yep, there you go. You can see the lines in the cylinder and the cover, and it's all based on, see if I can flip this around without messing it up, that center line there in the, don't show up too good, but the center height there, there you go, you can see it kind of right across there. So we'll proceed and drill and tap those holes, and hopefully we won't have to make another clearance thing. Okay, the top came out pretty good. Ended up keeping the top part silver soldered, it's crazy glued into my jig, and I put it into the clamping jaw that I used in the 5C collet chuck and drilled through, you know, because I had drilled from the bottom with the number 50 tapping size drill, but I needed to drill down for the clearance holes, the number 41 clearance holes. Also, I tested it with a little 256 screw, and it was, although it's a lot more symmetrical and it looks a lot better, there wasn't quite enough clearance for the screw heads, so I ended up cheating and I put in a 3/16 inch end mill and just went straight down to give a little bit of clearance, a small notch in the gland boss. You can see that one better. I think that'll be good. Okay, here's the finished product, thanks to those jigs that I made. Really happy with how things have come out. The left one, the right one, I didn't have to dimple the sides very much at all. Like I showed you a second ago, I used a 3/16 inch end mill just to make a little valley there, but it's hardly noticeable at all. Got the fronts on, the rears, and the next step in the process will be to make a couple of jam nuts in here that will hold the packing in, and then make the pistons, and then we can move on to the steam chests and the slide valves. Keep you posted as we go along.